Hello, this is my GCSE Science. In this video for triple chemistry only, we're going to be talking about corrosion and rusting. Corrosion is the destruction of materials by chemical reactions with substances in the environment. And this is normally a term used to refer to metals, where corrosion weakens the metal and sometimes even totally breaks it down. Some metals, like aluminium, form protective layers when they react with the environment. Aluminium reacts with oxygen to make aluminium oxide, which protects the rest of the aluminium from corrosion. But when metals like iron corrode, rust forms on the surface, which is brittle and flaky, so as it forms it starts to flake off, leaving more metal exposed, and this continues until the metal is completely broken down. As iron is an affordable metal that's commonly used for making objects in our daily lives, buildings, bridges, gates, chairs, bicycle chains, all sorts of things, rust can have the potential to be a big problem. So what causes rust? In the exam, you may be expected to design an experiment to show what conditions are necessary for rust to form, or you might be given some results and expected to interpret them. So here we've got a set of test tubes, each with an iron nail in them, and each with different conditions. First we've got just a test tube with a nail in it containing water, and it's open and exposed to the air. The second one contains boiled water, in which the oxygen has been boiled out of it, and then it's been covered with oil and sealed with a bung. The third one contains just air, but the air is allowed to flow in and out through the cotton wool. The fourth one contains air and anhydrous calcium chloride, which is a drying agent that absorbs any water that might be in the air. And the final one is similar to the first one, where we have just water and it's exposed to air, but this time the nail has been coated in grease. It's worth noting that the reaction of iron to form rust is a very slow reaction, so this experiment needs to be left for about a week in order to get appropriate results. So this is what you might be expected to see. Of course, depending on the actual conditions, you might get slightly different results, perhaps not as much rust on some of the ones you expect to rust, or maybe a little rust on ones that you don't expect to rust. But in general, this is what you'd expect. The first and third test tubes are the ones that would rust. In both of these test tubes, the nail is exposed to both water and air. It's a bit more obvious in the first one, but in the third one, although it only contains air, unless the atmosphere is completely dry, then air will contain water vapour, so over time, a nail exposed to normal air will also rust. In the other three, however, you wouldn't expect rust to form, or at least not very much. The second one contained boiled water, where all the oxygen in the water was removed, and then it was covered with oil. So although water was present, there was no oxygen or air able to reach the nail. In the fourth one, we had air, but the anhydrous calcium chloride kept the air completely dry, so rust didn't form because water wasn't present. And in the final one, although water and air was present, the nail itself was protected by a coating of grease, which stops the water and air molecules from attacking the iron. This experiment tells us that both air and water are needed for iron to rust, and in this equation you'll see why. The chemical name for rust is hydrated iron 3 oxide. You're not expected to be able to draw the symbol equation for this reaction, but it is worth knowing the chemical formula for rust. Iron 3 oxide is Fe2O3, and when it's hydrated, molecules of water are included within the crystal structure of the iron oxide. In some compounds, having the water molecule present makes the crystal stronger and more sturdy. But in rust, it makes it very, very crumbly. And this is the problem. So how can we prevent rust? Well, there are two main types of method that you can use to prevent rust. The first is a barrier method. Anything that creates a barrier that prevents water and oxygen molecules from reaching the iron will prevent rust. So coating the metal with paint, oil or grease, plastic, or a less reactive metal creates a barrier that prevents rust. However, this barrier isn't effective if it's been compromised, like scratched. Even a small scratch in the coating will allow a little bit of rust to form, and as soon as some forms, it can spread underneath the coating and through the whole metal. So if you've got iron or steel, under particularly harsh conditions, such as an oil rig in the ocean, or a bridge or a pier near the sea, or if the object's going to be used for a purpose where it might get scratched easily, then we need a more effective method to protect it. And this is where the second type of protection comes in, and this is called sacrificial protection. This is when the iron is coated with a more reactive metal. Metals such as zinc, magnesium or aluminium can be used to coat iron, and this reactive metal will react with the water or oxygen instead of the iron, thus protecting it. Because it reacts instead, it can be thought of as sacrificing itself, and hence the name sacrificial protection. Even if the rust does form, the more reactive metal can displace the oxide from the iron, therefore keeping it protected. And there's a special name when it's zinc that's used to coat iron, and that's galvanizing. So you may have heard of galvanized steel, for example, and this is where you have steel that's coated with a layer of zinc in order to protect it from rust. As I said, this is a more effective method, but it's more expensive, so it's only really used in harsh conditions. But the good thing is, you don't need to coat the whole of the surface of the metal. So for example, on a bridge, magnesium blocks might be placed on the legs of the bridge, and that can be enough to protect the rest of it. However, because the sacrificial metal reacts over time, then it needs replacing regularly. So there are two types of ways of preventing rust: the barrier method and the sacrificial method. But overall, there are 5 ways you need to know about that can be used to protect iron from rusting. And that's it for this video on corrosion and rusting. Here are a couple of keywords for you. Thanks very much for listening, and see you again soon on another video by My GCSE Science.